Hey, good afternoon, everyone. Thank you all for joining us today for our weekly webinar series. Today our featured topic is Fiber Asset Management Software. My name is Jessica Petrohoy, and I'm the Marketing Coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about fiber asset management software is Brent Lossing. Brent is one of our software developers at fiberoptic.com and the lead developer of FiberBase. So Brent will be discussing the importance of managing your fiber optic network with a fiber asset management software. When Brent is finished, we'll take questions from the GoToWebinar question box at the bottom of the screen for a question and answer session. So thank you again for joining us today, and at this time, I turn the presentation over to Brent.
Hello, as Jessica mentioned, my name is Brent Lossing. I'm primarily an application development programmer. I specialize in Oracle backends and GIS platforms. I've been involved with the application development and specification side of fiber asset management software for the past 20 years. So this talk is on fiber asset management software, and currently you should see the screen that has a title for this talk. And as Jessica said, everyone will be on mute. Feel free to ask any anonymous questions, and then I'll try to answer them at the end. So who does this webinar apply to? Software applies to many different areas of the facilities that install or manage a fiber optic network. So it goes from network sales, planning, and design, through build-outs to diagnostics and fiber usage after the fiber is in place. I'm going to give you an example of a couple of departments which fiber asset management software can benefit. So it'll benefit your sales and marketing in looking for new customer acquisition, your network engineering and ISP areas for documentation of ISP racks, access to records on route distances, customer information per fiber. It'll give you help in your construction engineering department for CAD construction drawings, using Street View to investigate work sites or obstructions en route, your construction maintenance for CAD design and OTDR route mapping, and your network engineering department. So what I'd like to cover today is it's kind of an overview, is your current state of your fiber network. Here we look at where you are today if you are not using some sort of software to manage your assets. Second is why you should use cable management software. What are some of the benefits that you should get from using software that's specifically geared towards asset management? The third is costs in adopting some sort of software, and that will be both as time and procedure kind of things. And the fourth one will be what features might be helpful for you to look for in a software system. So if we look at the first item, it's a current state of your fiber network. These are some of the problems that you have if you don't have any kind of asset management system. Generally, you usually have one person that's been involved with or supervised all of the fiber projects, and problems arise when they're out of touch, or you're on vacation or out on a job, or the network gets too big for one person to be at all the places at one time, or he remembers incorrectly how the network is actually installed. Of course, the worst is if he leaves. Another problem that people have is that they have multiple types and places where the data is recorded, and the data is not searchable. So you might have all the data for your network, but someone probably needs to coordinate in order to figure out any sort of diagnostic problems that you might have. For example, you might have construction drawings that are done in AutoCAD, the splicing is maintained in Excel, and customers that are using the circuit might be in a third place. So even though you have all the data together, you don't have any way of being able to correlate all that data together into one place. A problem that also happens then is that you get inappropriate rollout of either the construction or your diagnostic teams. The fiber splice is already in use, or it has been cut somewhere along the trunk that's not documented. There's no slack to pull it up into the truck, or the splice truck cannot fit in the location where the splice is supposed to be. The fibers you are splicing are in two separate enclosures. You have a company policy against installing jumpers. There's a fiber fault on one of the fibers you chose, but then you discovered that last year. You find that you're redoing work that has already been done before. You have to keep doing field audits to check which fibers are in use. You're redoing drawings because the contractor just gave you a hard copy of the work, and you do not trust the red lines that you are making are being kept up to date. You find that you're reshooting traces because construction traces have been lost or misplaced. So you're looking for a more effective solution. Perhaps you already have your network data together, but somehow you feel that it can be more effective. Some of the data might be overloaded. For example, the name of the cable might also indicate how many fibers you have in the cable. So how do you find out what circuit it is that is riding on that cable? You can't track multiple wavelengths on that same fiber. Maybe something as simple as no graphical displays to easily show the data that you have in a meaningful way. And perhaps you've been using a twisted pair coax system for years and it really does not adequately support your moves to fiber. So what that brings us to is, why should you use cable management software? Once you have identified that you have a problem, you start looking for a solution. One of the main benefits is that you have a centralized data repository. Having all the data in one storage place has many immediate benefits. For example, the first is consistent data display for all departments. Sales, engineering, and construction are all using the same data set. Having one common database also allows for a consistent use of materials. So it allows for a known procurement process, a process of training workers in the field on one set of hardware, and a consistent use of tools for installation and diagnostics. It gives you the ability to search the data, for example, to find all the fibers that you are leasing from a vendor company, or finding out where you've been having the most faults and what kind of equipments are involved. You're also able to create repeatable reports. So that means that when sales and network engineers have confirming results of the available fiber or fiber that's in use, it builds a level of trust within the company that a plan of action is not going to be subverted by discoveries out of the field. As soon as the data is entered into a software system, it's on one person's computer, you have access to it everywhere. Finally, centralizing the data means that you have data that reflects history, not just the point it was engineered, but also as that network evolves. What this means is that you can find all of the equipment that was installed 10 years ago or installed by a certain contractor, and all the moves, adds, and changes that have occurred since that time. Having a fiber asset management system also allows for efficient use of assets and resources. Again, it's impossible to make an accurate cost assessment if you do not know what fiber assets you have in place. If you have to guess at the number of splices, what network gear you have available, whether you have leased the fiber that is available or promised it on another job, you are going from one crisis to another, or not getting the jobs because you have incorrectly priced yourself out of the market. Consistent use of similar resources leads to efficiency in repairs in the field, costing and quoting, training, etc., etc. It allows you to track which fiber spans are faulted, what the cable type is, when the fiber was procured, and who you bought it from. This allows you to know whether you have an isolated problem, a problem with the whole reel, or perhaps even a problem with a whole brand of fiber. You're able to track percentage of usage. So you can look at a table and see how many fibers are available to you, or look at the equipment in a rack and be able to tell which panels are connected up already, and out of those that are connected, which fibers are in use. You're able to track dead fiber. So after you've made a ring cut, you're able to see which fibers are in use on one side and which ones are still available on the other side. You have all the data. Having all the data allows you to be able to utilize existing fibers and splices for cost-effective installation versus putting in all new fibers and ducts and equipment for a new project. Using the proper software allows you to be able to create diverse routes using existing fiber or empty ducts in the ground. Next, when you look at diagnosing problems, when you see the pattern of outage problems geographically, it's easier to see where and how to attack a problem. If you shoot an OTDR trace, you should be able to see where the fault lies on your fiber network. Current tools allow engineers to have their diagnostic OTDR teams shoot their traces in the field, and the Network Operations Center to have immediate access to that data for troubleshooting. When you have a problem with a cable span, the software gives you the ability to know who is affected so that you can contact them first, or at least let them know you have people in the field working on the problem if they call you. With proper tools, you can prioritize who to fix first. You'll also know where and with what assets you will need to fix a problem. Proper fiber asset management systems will also allow you to monitor and store fiber characterization data for each of your fibers. Fiber characterization benefits allows you to determine if a fiber topology has the proper characteristics for the band at which it will be performing at. Will this, for example, will this fiber support 40 gig signal? With fiber characterization, you can determine if fibers were properly spliced, polished, and connected. You can also determine if proper fiber was used throughout the fiber span. Having the ability to archive the data, such as construction OTDR traces, CD, and PMD, allows you to come back at any time to ensure that a new span under consideration for use has appropriate characteristics for circuits that will be riding on it. It's also an important diagnostic tool for determining fiber degradation over time due to weather, flooding, bends, or other environmental factors. And finally, you should be able to look at taxes. A good fiber asset management system will be able to report for tax purposes on length of fiber, the cable and ductwork both within and across a region, as well as by ownership and whether it is leased fiber. So let's look at some of the costs in adopting software. The first cost to you will be a change of procedure, and you'll need company buy-in. So you need to re-educate the workforce and come up with a new way of doing tasks that workers were already familiar with. Perhaps this means that when a worker goes out to make splices in the field, they need to do an audit of what is there and bring back a detailed drawing. You will need at least someone responsible to keep the records up. Finally, you'll need somebody from management to do things in a different way and accept the costs associated with the transition. For a while, you're going to be maintaining 2 sets of records while getting the system up. Until you have enough data in your new fiber management system, it will not even be as effective as your current system. Most companies have to rely on double entry of the data until the fiber asset management system has truly replaced their old system. Another new cost will be that of system maintenance. You have the necessary IT staff on hand to maintain the network, deal with licensing issues and database maintenance. If not, it may benefit you to look at a cloud solution where the software and the database is maintained off-site. Usually this means a slightly higher cost per year and slightly slower performance. But you get a willingness to trust this. You have to also have a willingness to trust the security of data that is not being maintained within your own offices. For some government types of network, offsite or cloud storage is not a possibility. A final cost is data migration. Your data may not be the best, but is what you're currently using to track existing customers. One of the advantages of using software data migration is that data integrity is maintained. This is a good thing when you have accurate GIS information for routing and structures, and perhaps a bad thing when the data is inaccurate. It's important when purchasing the software to come to terms with where your current data store is at. Is it beneficial for you to use as a starting point in your new system? Before you start data migration, it's important for you to have gone through training in the software you are going to adopt. Make sure to have a copy of the software so you can experiment with how your data will look in the new software. If the vendor does not have a canned piece of software for migrating your data, it will benefit your end product to get involved with how your existing data maps over to the new software. There are some common things that you'll need to engineer. Determining the process and timing of how and when to map your data. What will be done with custom scripts, what to do with canned software, what requires manual data entry, etc. Determining how you are going to use your data. This usually involves several different departments, even in a small office, sales, finance, construction, etc. Often in a custom data set, you're going to have to end up parsing overloaded data fields. It is common, for instance, for cable name to have packed into its name the start and end locations, the fiber count, and types of fiber. You're going to have to learn a new nomenclature. There are going to be different names for the same thing. For example, cables might now be called sheaths. Spans might now be called fiber topology. A circuit might now be called a transport. You will need to decide what to do with the data that does not map well into the new system. You may be tracking something for the new something the new software does not. For example, power available at remote sites, or PDF documents for the right-of-way, or hard copy AutoCAD as-built construction drawings. You're going to need to deal with data sizes. Is 40 characters for our cable name enough? You're going to have to look at data types. The software has purchase orders as numbers. Yours are all mixed characters and numbered. You're going to have to look to see whether or not the software supports units of measure. And is your current data, when you're migrating it, is it all in feet, or is it a mixture of feet and meters? Finally, with the data migration, you're going to have to determine what to do with the data integrity issues. Data that just does not make sense. For example, if you're splicing coax and fiber, one cable end that terminates in two separate manholes, 3 fibers that are spliced together, those kinds of problems. What do you do with these? You just leave them and let the new software accept them as it is? You create an error log and through successive passes of the data migration, fix the data in the original data set? Or do you create an error log and fix them in the new software as time permits? All this needs to be resolved in order to ensure that you are pleased with the end result. So here are some features that you should be looking for. You should be looking to see that it has, you should be looking at its GIS or mapping portion of the software. Your software should be able to work with freely available maps. Be aware that some companies either lease or limit the amount of map usage available to you. There's a lot of free map data available on the internet. Is there a way to get that data into your new map software? What if you've been using AutoCAD Map 3D? Does your software you are looking at have a way of displaying those maps? The labels that show up on your map should be configurable. You should be able to view the data on all layers below the cursor. There should be adequate control of the layers so that they can be displayed how you want and at the zoom level you want. Looking at all the streets of the United States when you're zoomed out to the whole United States is just going to take too long and you're going to get very frustrated with your software. Information on mapped objects should be accessible either via selection or a single mouse click. For example, in an AutoCAD drawing, you may draw out all the fibers in a FMS system on a map you see. You may have, and on the map you may just see a single line on the map. The software should have a mechanism for seeing a cross-section of that portion of the network. So when you're looking at a network on the map, you should be able to click on it, be able to see all the fibers in the map, fibers that are in the cable that you're looking at, all the ducts that are in a given route, and you should be able to see all the customers and all the different wavelengths that are traveling on each individual fiber. You can't display all this data on the map at one time, so the software needs to have an easy way of being able to view this data. You should have the ability to have different kinds of icons for different types of structures. So you should be able to have icons that represent poles, manholes, etc. These should all be user customizable. After using Google Earth for a while and using different colored push pins to represent different data points, you can readily see how helpful it would be to have a manhole icon for a manhole, a pole icon for a pole, a building icon for a central office, pedestal icon for a pedestal. You should be able to design and import your own icons for ones that make sense to you. Line styles and colors for the cable routing should be user configurable. If a cable is aerial, you should be able to draw it as blue, brown if it's underground. You should be able to have a dash line for leased fiber and a solid line for fiber that you own. You can get a lot of visual information from just a few pneumatic clues. Software should be able to take advantage of underlying map data to speed data entry. If you have a cable routing that follows the street, you should be able to just select that street and use its data point. You shouldn't have to click on each individual bend in the street. For creating a region, you should be able to use one or several county boundaries and be able to collect those up to form one polygon within the mapping software. You do not want to re-engineer data that already exists. The map should be configurable through queries. You should be able to display only the cables that belong to a certain customer or view only those cables that are leased. You should be able to show all of your data all the time. If you show all of your data all the time, it makes it a lot harder to decipher what you're looking for. Once you have configured a map, you should be able to save it for later recall. Utilities should be provided for calculating sheath and fiber length from the map. Utilities should also be provided for calculating the length of duct fibers and sheaths that are within or lay across the region. Cable routing should also include ductwork. Users should be able to see both the topology of the circuit on the map as well as a cross-sectional view of the cable to see individual circuits within the cable. When you're dealing with connections, the user should be able to display all the connections that are made within a structure as well as a subset of the connections that apply to a new build. So if you're looking at 1,000 count cables, you might only be wanting to look at a series of fibers that are only leased to a certain customer. You should be able to look at only those fibers. The user should be able to collapse the sheet to show only those. So the user should be able to collapse those fibers of interest. And you should also be able to collapse it so that you're only looking at the binders and not all the fibers all at once. The software should have the ability to do straight-through connections, cable to cable, with just a few mouse clicks. You should also have the ability to do patch connections very easily. The user should be able to perform ring cuts, and fibers that are passed through are are not cut should be easily identifiable. So when you're do a ring cut on a fiber and you're only pulling out a couple of the fibers, you should be able to look at that cable in your connection display and be able to see which ones were cut at that manhole and which ones just passed straight through. The user should be able to make several ring cuts within the same manhole. For example, when you're threading a sheet between splice cases within one manhole. When you're looking at circuits, a circuit should be able to be assigned on a specific wavelength. You should have support for as many wavelengths as you can see in the future. For example, 100 wavelengths should not be out of the question. It would not surprise me if in the future we end up with 1,000. The software should be able to support as much data space as you have available to be able to support that many wavelengths on a fiber. Customers that are assigned to, leased to, and owned by field should be available on each circuit, fiber, port, and the equipment. When a circuit is assigned to a fiber, that circuit should be propagated through all the fiber and equipment connections without having to assign the circuit on each individual fiber. It should be easy to see which customers are on which fiber in a sheet. Each fiber should have a priority associated for outage service. Systems should support fiber, coax, and twisted pair. And systems should also support power and loss budgets throughout a circuit. When you're building equipment and sheet, it really helps to be able to have a template that you can use to be able to create it, so you don't have to design your equipment each time. A good fiber asset management system will have a number of pre-built ones that you can use as a model for building your own, or be able to use those for building your circuit, how they exist. There must be a custom way to be able to build up your equipment and cable as vendors and things change. When you're looking at your fiber, it's the length of the fiber as well as its twist factor within the sheet. It should be tracked. There should be a color representation of the fiber of the sheet so that you can look at the cable and identify it both as a color or as a name. The software must support splitters, combiners, switches, pass-through ports, as well as all ports on the front or the back of the equipment for WDMs and DWDMs. Other features that you should be looking for are fiber characterization. The software should be able to store and link any number of OTDR traces to any fiber. Each fiber should be able to track forward and reverse engineered and actual loss, pneumatic dispersion values, polarization mode dispersion values, and each fiber should track the index of refraction by wavelength. It's helpful if your software has the ability to track projects and work orders, or be able to link to another software program that does track projects and work orders. That software should have start, end, and due dates, should be able to track work hours and costs, both costs as billable hours and also costs as bill of materials. Software must support querying of people to see which projects they are currently working on, and you should be able to export it out to like an Excel spreadsheet so you're able to do costing and bill of materials out in Excel if you rather use Excel. Your maps, a lot of people are using Google Earth as a way of being able to look at their maps. So your maps should be able to be exported as KML files. Your reports must be exportable in a CSV format, and they must be printable with headers and footers. When you're looking at taxing in a regional area, you should be able to track within a region fibers that cross across the region and are totally within the region, and you should be able to see how many ducts are there, as well as the fiber count and fiber length. For queries, the user should be able to perform and save custom queries against the database, and it should have a friendly user front end for doing the queries. You shouldn't have to go into Oracle or SQL Server to be able to do all your queries to get the data that you need. You should be able to also do mass change of a status, for example, based on the results of a query. So if you want to change all your fibers from being available to being in use, you should be able to select all those fibers, perhaps from a project, and then be able to do some sort of mass change that shows you that they're now in use. Software must provide for a read-only user, and the software should provide who is able to change or write to an object via a group of users. So you should be able to go down to the fiber or the circuit level and be able to put some sort of security that prevents other users from changing it if you don't want them to. One thing that helps a lot is the ability to have thematic coloring that's consistent throughout the software. We talked a little bit earlier about, for example, having different line characteristics for whether something is leased to a company or assigned to a company, having different colors for whether it's aerial or underground. It also helps for showing when you're looking at an equipment rack, if you can show all the ports that are currently connected to cables, if you can change that also to show status, so you can see all the ports that are currently faulted or they're designed for being in use in the future. They're on a project. They haven't been installed yet or turned up. Lastly, I think that what you should be looking at is an open system. And what I mean by that is that your database shouldn't be closed. You should be able to query against your database with third-party tools and not have to rely just on the software that you've bought. Where this helps with is when you're not able to get certain kinds of data that through the fiber asset management system, you're able to use Oracle to create custom reports, or you're able to use a third-party tool to be able to pull that data in. So in conclusion, what we have covered today are 4 major areas related to fiber asset management. We looked at the current state of your fiber networks, where you are today if you're not using some sort of software to manage your assets. We looked at why you should use cable management software. What are some of the benefits of using software specifically geared towards fiber asset management? Third, we look at costs associated with fiber asset management software. What are some of the costs associated with adopting fiber software for the first time or moving from one software system to another? And finally, we looked at what features you should look for in a software system. So, looks like I should have updated this to the some of the next webinars. But there is webinars coming up for fiber characterization, DWDMs, fiber optic network design, and you can look at our webpage here, fiberbasenms.com, to be able to see our software, which is Firebase, and be able to get any information about Firebase there. If you want any demos of our software, you can email at fbsales@fiberoptic.com. And I'll open it to questions if you have any questions. Otherwise, you can send questions here as well, fdsales@fiberoptic.com. Okay, so with that, I think I'll close up the webinar. I appreciate your attention and thank you very much for attending today.